The working of a circuit breaker. So how these circuit breakers work? The main purpose of the circuit breaker is to protect the house units. Like for every room, there's a separate circuit breaker rather than a device. Let's say that this is a home plan, like the map, and you have a living room, then you have a lounge. So we have different rooms are there. Why people use a fuse rather than a circuit? One thing is, number one, the circuit breakers small circuit breakers are, like example, 2 ampere, 3 ampere circuit breakers are rare, hard to find. You have a circuit breaker with a high values, but the devices like need 2 ampere to work. So circuit breakers are usually big. It's hard to install on the socket, and it's also expensive compared to that of a fuse. A fuse and a circuit breaker, yes, it can be connected in the same circuit, but it does not make sense when you're connecting them in the same circuit. Like for a device, yes, it is. It can be for devices. It can be individual. So let's say we have this is a home plan. This is room one, room two, which is having more sockets. Room three, like example, a kitchen is there, and this is a kitchen. So every room, according to its need, like according to the number of socket, it need different amount of current to work. So example, your room one need maximum 13 ampere to work. Your room two, because so like example, your room two need 30 ampere to work. Your room three, let's say, need maximum 10 ampere, like less sockets are there. And this kitchen is there, let's say it need 15 ampere. So the household circuits, the outer unit will have a main circuit board. And you will see usually the main circuit boards are there in the entrance of the house on the wall. I'm drawing it like this vertically, and it is having buttons. And these are connected to the live wire, like the whole, this is connected to. So if this is a 13 ampere, so this is connected to 13 ampere. This one is connected to 30 ampere. This one is connected to 10 ampere, and this one is connected to 15 ampere. So how this circuit will work, how a circuit breaker work in the circuit. So every circuit breaker is having a unique rating. If I say the first circuit breaker, it's having a rating of 13 ampere. So if the current is 13 ampere in that room, it will work normally. It will allow that current to pass. So if your current is 13 ampere, it will allow that to pass. But let's say the current is 13.1 or 13.2. That small increase in the current, what will happen? Because of the magnetic effect, the switch will open. Like it is connected here, but as a result, the switch will open. So the circuit breaker disconnect the whole circuit. So in that room, there will be no electricity. If the current is more than 13 amperes, so according to the need of that room, circuit breakers are installed. If a room is having more sockets, definitely it will use more current. So it will have a high circuit breaker. Plus, it also depends on what are the devices connected in the room. If a room is having a devices such as air condition, a motor, a washing machine, let's say, and or electrical heater, so definitely that room will have a circuit breaker value rating will be higher than the other rooms which are using only a fan or a light. So circuit breaker use same as the same effect that work in the same manner as the fuse, but the only is thing is that the fuse use the heating effect of the current and it melt, where circuit breaker use a magnetic effect and it just open the switch. Then what we just have to do, we have to reset. But this is a protection. Like example, let's say if you have a short circuit, like in the room, if you are working and your live wire touches the neutral wire, so in case the live wire touch a neutral wire, there will be a short circuit. When there is a short circuit, it means very low current, low resistance, so more current will come from the supply. So that might start a fire and it will burn the whole house or a room. So, just to prevent a short circuit, if a live wire may touch the neutral wire and lot of too much current may enter that room, which produce lot of heat energy and can start a fire, we use this for a safety. We use the circuit breaker. So safety circuit breakers are mainly used to protect the units like rooms, apartment, houses. That's the main purpose of the circuit breaker in case of a short circuit. It just automatically trip or switch off. Is it clear? The concept of the circuit breaker?
Yes,
Any doubt in this?
no, sir, clear.
If you have a question, I prefer you can use mic because lot of students are asking question in a chat. I am trying to read maximum out of it, but in case if I miss your question, you can use your mic. Can a fuse and a circuit breaker connected in one circuit? Yes, it can be done, but it does not make sense. That is what I answer first also. If you connect a fuse and a circuit breaker in the same circuit, so it won't work. Like it will work, but it's not effective. In the main socket, there is so much current. So how does it provide a specific amount of current? What stop 100? Because every device is having a unique resistance, and that is why, like example, when you're using a television, it is taking 3 ampere to work. When you're using a mobile for a charging, it is using 0.01 ampere to work. The resistance is a property of a material to which restrict the current. So different devices have different resistances. That's why different current will pass through. What should be the position of a circuit breaker and the fuse if you want to connect them? So this is the same question Ayan you was asking. Can we connect a circuit breaker and a fuse in the same circuit? Yes, we can. But the question is which position if we want to connect, which position a circuit breaker should be connected and which position a fuse should be connected. So where we should connect a circuit breaker and a fuse. You can use the chat to answer. Till now, no one answered correctly. Till now, no one has answered it correctly. Now, now some of them have answered, and that is correct. The correct answer for this one is A. Why A? The fuse and the circuit breakers. If you want to connect a fuse or you want to connect a circuit breaker, both should be connected on the live wire. If I want a fuse, it should be on the live wire. If I want a circuit breaker, that should also be on a live wire. Because if I connect a fuse or a circuit breaker here, it does not make sense because the current will come from live wire and enter the apply. So the main purpose is to protect the device. So main purpose is to protect the device rather than protecting the live or a neutral wire. So fuse and circuit breakers are always connected on the live wire. That's why A should be the right answer for this. Then to protect from electric shock, what we should use a double insulation. What is a double insulation? Double insulation means like two insulation layers are there. If you have a conducting wire, a copper is there, conducting material, I mean, then if it is carrying too much high current, then we have two insulation. So what is the advantage of using two insulations rather than one? So if the one of the insulation layer is damaged, like the top layer is damaged, the other will protect. And you have seen this double insulation in air condition or iron wires. You have seen that because or a heater also, double insulation is there. Because when a device use high current, it produce heat energy as well. So the insulation might be melted or a damage. That's why we prefer to use a double insulation. Earthing. What is the purpose of the earthing? The earthing is to protect the person from getting electric shock. The purpose of the earthing wire is to protect the device from a person who's using the appliance from getting an electric shock. How this works? So you have seen a three-pin plug. In a three-pin plug, we have one is for the live wire, another one is for the neutral, and the third one is the earthing wire. Okay. So most of the student mentioned it's not lagging. Some of them, in case if it lag, I will stop for some moment. How we use this? Let's say you're using a refrigerator. The refrigerator body mainly it's made up of like conducting material. Top part is there insulation. Now, when we plug in this, when we plug in the device into a socket, there's a connection between the live and like the connection is there. So the current start to flow through from a live wire, enter the circuit and then return back. But what if the live wire is touching the metal body? If there's a connection between a live wire and the metal case, metal is a conductor. So as metal is a conductor, if you touch the refrigerator, then what will happen? The current start to flow through your body because your body is also a conductor, so through the metal and it will pass through you. So a person will get an electric shock. So if you want to protect the person from getting an electric shock, so there is another wire which is we called an earthing wire that is connected to the metal body. The another wire is there which is connected to a metal body and that is in the three pin. So what is the advantage of connecting this earthing wire So whenever, in case if a live wire may come in contact with a metal body, so there's a short circuit. So to protect a person from getting an electric shock, the additional current will flow through the earthing wire. So a person who's touching from the other side, a person will not get an electric shock. So to protect the person from getting an electric shock, we use an earthing wire. So we have a device, as you can see here. See, this is a device, a kettle is there. When we close the switch, the current start to flow through the fuse. A certain rating is there. In case if a live wire is touching, it passes through the circuit. In case if a live wire is touching the metal body, the additional current will flow through the earthing wire, return back. So if a person is touching the kettle, touching the object, he will not get an electric shock because metals are conductor, a good conductor. Metals are good conductor as compared to a human body. So in this is only in a case that if a live wire may come in contact with a metal body, the body start to conduct, and if a person will touch, he will get an electric shock. And what is the reason why there are because to insulate from the ground, that's why also the refrigerators are always having a insulating base as well. Like the base of the refrigerator is also insulating. Is it clear, the concept of earthing?
Yes, sir.
So main purpose of the earthing wire is to remove the additional current. So live wire, what is a live wire? A wire connected to a source of a voltage is called a live wire. What is a neutral wire? A wire which complete the circuit. It does not have any voltage or zero potential. And what is the earthing wire? It is a safety wire which connect to a metal body of electrical appliance to the earth. After some building work in a house, a bare uninsulated live wire is left protruding from a wall, like touching the wall. What is the greatest hazard? What is the greatest hazard if a bare uninsulated wire is there, which is left on the wall? Like you can use the chat to answer.
What, sir, what is the question you asked?
Use the chat to answer. Can you see the question on your screens? So what is the greatest hazard here? So the correct answer for this one is C, that why C is the right answer for this? Because an uninsulated or a bare wire, so it can give us electric shock. Now, the next figure you can see, we have to identify any dangers of, in this picture, we have to identify a gardener is there who's using an electric mower in a damp glass, a waterproof socket is there. Can you identify the dangers here? Anyone of can see the question? Just a minute. I will just refresh. Can you see now? Yes. Is it visible? The screen? No? Okay. Just a minute. So here in this one, figure 9.1 shows a gardener who's cutting a damp grass with a high power electric mower. Different conditions are written. Excess of a length is there. Waterproof socket on wall is there. Extension cables with thin wires. Plug is there. Then socket designed for indoor. There's a cut in insulation which is covered with a uh, tape and damp grass. So the question is, mover cable has a thick wire. Yeah, I have zoomed in. I have zoomed in just to discuss the question and now zoomed out here. A mover cable has a thick wire appropriate for a current to a mower and a correct fuse. The cable is too short, so the gardener uses an extension cable with thin wires, intent for use with a reading lamp. The cable has no fuse. Discuss the dangers of electrical arrangement shown in figure 9.1. What are the dangers you see here?
Because of thin wire, there can be overheating, and then because of no fuse, the electric mower would blast or something like that. And
Yeah,
because
good.
of that, damp grass would catch fire and
Good.
some
Anything else you see? Anyone want to add?
the cut in insulation. There could also be a electric shock.
Electric shock because it's a moist insulation. And another thing, socket design for indoor use, not for outdoor use. And
Damn grass.
yeah, damp grass, excess length of a cable coiled up, so that will also produce like all the cable is being coiled up, like very long cable is there and all is coiled up. The socket, this is a weatherproof socket on the wall. So the socket, you cannot mention anything related to a socket because the socket is weatherproof. So no need to mention, but you can mention cut in the insulation. You can mention damp grass. You can mention no fuse is there. It will damage. Too high current might be there. A socket is designed for indoor use. May start a fire. Yeah, damp means the wet. Yes, yes. You can say no fuse as well. That's fine.
Sir, can we say that there is no earthing wire? Or there is earthing wire. Like if there is no earthing wire, then the guy could also catch a electric shock.
Yes, you can mention because any not relate. They did not specify that the wire is earth. So you that is another possibility. Is it clear this one?
Yes, sir. Yes, sir, clear.
Okay. So that's about topic 4.4, which is about electrical circuits. Next session, we will do some practical like planning experiment. Any question or doubt related to the class?
No, sir,
About the
clear.
circuit breaker, no need to mention about circuit breaker. What is the difference between earth and electricity? Earthing wire is removing the excess. When excess current is removed, that we use an earthing wire.